So I had a question that I was trying to answer. It was one of the example problems from relative rates, and I kind of muffed it on the solution. So I'm here to try to redeem myself a little bit. Anyways, so the rocket lifts off at Kennedy Space Center in Florida. A camera is placed 2,000 feet away from the launch pad to film the rocket's ascent. The height of the rocket can be found by S of t equals 50 t squared, where s is in feet. So this is the position function as it's lifting off vertically, and t is in seconds. Find the rate of change in the angle of elevation of the camera at t equals 10 seconds after liftoff. Okay, so here we go. First, we want to draw a picture to see what it looks like. So here's the angle of elevation for theta. This is going to be s of t, function of time. The position function is 50t squared. That's your vertical distance and is 2,000 feet away. So looking at this right here, since we're given the opposite side and the adjacent side, if you recall, that was tangent. So we have tangent of theta is equal to 50 t squared over 2,000. Canceling one of those zeros out in the back, 5 over 200 is going to be 1 over 40. So tangent of theta is equal to 1 over 40 times t squared. So what are we going to do with this? We're going to take the derivative with respect to time on this, because it's a related rates problem. The derivative of tangent is secant squared of theta times the derivative with respect to time of theta. That's d theta dt. That's equal to 1 over 40 constant times the power rule. It's going to be 2t. Take the power, bring it on down, and then subtract 1. That's going to be 2 over 40 is 1 over 20t. So secant squared of theta times d theta over dt is equal to 1 over 20t. So what do we do from there? We move the secant squared divided by c squared to both sides, secant squared to both sides, divided by secant squared to both sides. You get d theta over dt. It's equal to 1 over 20 t times what's 1 over secant squared is going to be cosine squared of theta. Okay, so secant was the reciprocal function of the cosine. So 1 over secant squared is going to be cosine squared. So this is at t equals 10 seconds, right? Now we can plug in d theta over dt to 1 over 20 times 10. That's 1/2 right there. Times cosine squared of theta. So, well, we got to figure out what the cosine of theta is. I know that this is going to be 22,000 on the denominator. It doesn't move. The camera was 2,000 feet away, which is angle theta. And at the position at 10 seconds was 50 times 10 squared. 10 squared is 100. 100 times 5 is 5,000. Okay, so we're looking for cosine theta. We don't know what the hypotenuse is. So looking at the right triangle right there, c squared equals 2,000 squared plus 5,000 squared, which is equal to c is the square root of 2,000 squared plus 5,000 squared. So d theta dt as 1/2 times cosine is going to be adjacent over hypotenuse. So it's going to be 2000 over the square root of 2000 squared plus 5000 squared. And that's going to be squared, the whole thing. Because it's cosine squared of theta. So let's figure out, this is where the mistake was. It's a little trivial thing. Not so trivial, but make sure that you get your numbers right, right? It's 1/2 times 2000 squared. It's going to be 4,000,000, 4 million over 2000 squared plus 5000 squared. 2000 squared is 4,000,000. The square and the square root cancels, right? 4 million plus 25 million. And 4 million plus 25 million is 29 million. These cancel, these cancel. The 1/2 and the 4 cancels to a 1 and a 2. So you end up with 2 over 29. That's the correct answer. I'll show you in the bottom. And it's going to be radians per second. That's your unit. And 2 over 229, if I remember correctly, was approximately 0.069 radians per second. Let's scroll down. Oh, 0.069. Yes, 0.069 radians per second. Perfect. Hope you learned something. Remember, it's the concept, right? The concept is that how does the angle change with respect to time? And you have the rocket going up at 50 t squared, and the distance from the camera, which is right here, to the rocket is 2,000 feet away. Good luck.